We'll show you how to calculate the pH of a solution formed by mixing a strong acid with a strong base. We'll consider adding equal amounts of a strong acid and a strong base to the beaker on the bottom. Strong acids contribute hydronium ions to aqueous solutions. Acids can more simply be viewed as donating protons or H+ ions. Here we'll consider acids as a source of H+ ions, and bases as a source of hydroxide or OH- ions. When a strong acid is added to a container, it brings H+ ions with it. And when a strong base is added, it brings hydroxide or OH- ions with it. Of course, when the base is added, it immediately mixes with the acid. However, we'll pretend it doesn't mix yet, so we can get a more detailed idea of the process. As the solutions mix, H+ and OH- ions move toward each other, and in the process of neutralization react with each other to form water. And the spectator ions in the acid and the base will be present as a neutral salt. Now we'll use a slightly different model to visualize adding a strong acid to a strong base. In this case, we'll start with equal moles of H+ and OH- and move these together. The H+ and OH- will neutralize each other to form water. And there is no strong acid or base left over. So the final mixture is neutral. This time, the acid we're starting with has more H+ than the base has OH-. The H+ is in excess. Each OH ion will neutralize an H+ ion to form water. But since we had started with an excess of H+, we have some H+ left over. There weren't enough OH- ions available to neutralize all of the H+ ions we added. Because there is H+ left over, the final mixture is acidic. Now we'll look at another combination. This time the base we're starting with has more OH- than the acid has H+. The OH- is in excess, so we combine them. Each H+ ion present will neutralize one OH- ion to form water. This time we have an excess of OH- left over. So the final mixture is basic.